Ever pondered over how machines predict outcomes based on data? Welcome to the world of simple linear regression, a type of regression algorithm in the realm of machine learning. This algorithm models a linear relationship between a dependent variable and a single independent variable. Imagine a sloped straight line graphically representing this relationship, and you've got the gist of it. In simple linear regression, the dependent variable is a continuous or real value, while the independent variable can be either continuous or categorical. The algorithm has two key objectives. First, it models the relationship between two variables. Think of the relationship between income and expenditure, or experience and salary. Secondly, it's all about forecasting new observations. Picture weather forecasting based on temperature, or predicting a company's revenue according to investments made in a year. With the foundation set, let's delve deeper into the simple linear regression model. Now you might ask, what does the simple linear regression model look like? Well, it's actually quite straightforward. It's embodied in a simple equation. Y equals a 0 plus a 1 times x, plus an error term represented as epsilon. Let's break that down. Y is our dependent variable, the one we're trying to predict or explain. X is our independent variable, the predictor. A 0 is the intercept of the regression line, which is the value of y when x equals 0. A 1 is the slope of the regression line, and it gives us the direction of the relationship between x and y. If a 1 is positive, y increases as x increases, and if a 1 is negative, y decreases as x increases. And lastly, we have epsilon, the error term. It's the difference between the actual and predicted values of y. For a good model, it should be negligible. Understanding this equation is key to grasping how simple linear regression works. Theory is great, but seeing it in action makes it even better, right? Let's breathe life into our understanding of simple linear regression with a practical example. We'll work with a dataset that includes salary, our dependent variable, and experience, the independent variable. Our goals are threefold. First, we aim to determine if there's a correlation between these two variables. Does experience influence salary? If so, how strong is this relationship? Second, we'll identify the best fit line for our dataset. This line will help us visualize the relationship between experience and salary and how closely our data aligns with this linear model. Lastly, we will observe how changes in the independent variable, experience in this case, affect our dependent variable, salary. This will give us insights into how much a person's salary might change with additional years of experience. A practical example always helps to cement theoretical knowledge, don't you agree? So, how do we go about implementing simple linear regression using Python? Let's dive into it. The first step is data pre-processing. We start by importing 3 essential libraries: NumPy, Matplotlib, and Pandas. These libraries will help us load the dataset, plot graphs, and create the simple linear regression model. Once we've imported the libraries, we load our dataset. For our example, we're using a dataset with 2 variables, salary and experience. With our dataset loaded, we then extract our dependent and independent variables. The independent variable is years of experience, while the dependent variable is salary. It's important to note that in the code, we've used -1 for the independent variable to exclude the last column from the dataset. For the dependent variable, we've used 1 because we want to extract the second column, and remember, indexing starts from 0 in Python. And there you have it, a step-by-step guide to implementing simple linear regression using Python.